there are only 9 days left now of the math countdown series. That's single digits, just over a week left. So make sure you stick around until the end. Okay, so we need to sketch the domain of this bivariate function. Well, what are the things that are going to place a restriction on the domain? Well, we know our denominator can't equal to 0, and we know everything inside our square root has to be greater than or equal to 0. And if we were to have a tan function, then we'd know that tan is not defined at pi by 2. And if we were to have a log function as well, then we'd know that everything inside our log is greater than 0. So we have to be careful about all the things that can place restrictions on our domains so that we know what our domain actually is. So in this case, it's just the denominator and the square root. So our denominator of y minus the absolute value of x, of 2 minus absolute value of x minus y, that can't equal to 0. So rearranging this and isolating y, we have y cannot equal to the negative absolute value of x plus 2. So that's our first restriction over there. But we also know that everything inside our square root has to be greater than or equal to 0. So then y minus x to the 4 over 2 minus the absolute value of x minus y must be greater than or equal to 0. And this can happen in two ways. It can happen if both our numerator and denominator are greater than 0, or if both our numerator and denominator are less than 0. Obviously, it can't happen if one of them is greater than 0 and the other one is less than 0, because in that case, what we'll have is a negative function, and we strictly need a greater than or equal to function. Okay, so case 1 for this is where our numerator, y minus x to the power 4, is greater than or equal to 0, and our denominator, 2 minus the absolute value of x minus y, is greater than 0. And this is greater than 0, not greater than or equal to 0, because our denominator cannot equal to 0. Okay, so rearranging this, we get y must be greater than or equal to x to the power 4, and rearranging this, we have y must be less than negative absolute value of x plus 2. And we can see that that's right because I just moved the negative y to the other side of the equation, or inequality. Okay, so that's case 1. Now, let's look at case 2. This is when they're both negative. Okay, so we have y minus x to the power 4 less than 0, and 2 minus the absolute value of x minus y less than 0. Okay, so rearranging this, we get y must be less than x to the power 4, and take this y to the other side, we get y must be greater than the negative absolute value of x plus 2. Okay, so here we go. We have our two restrictions on our domain, our two defining properties of the domain. Okay, so let's go ahead and try and draw this. So here are our axes, our x and y axis. And now we need to look at the defining curves of the domain, which is the negative absolute value of x plus 2 and x to the power 4. So what does negative absolute value of x plus 2 look like? Well, the absolute value of x looks like something like that. So negative absolute value of x looks something like that. And we shift that 2 up, so negative absolute value of x plus 2 looks something like that. And our x to the power 4, we know that this looks something like this. It's not the neatest, but you get the general idea. There you go. Let's move this curve to be slightly flatter at the base, because we know x to the power 4 is slightly flatter at the base than x squared. Okay. But now, note something. Our x to the power 4 is always going to be greater than or equal to. And here it should be less than or equal to. So x to the power 4 is greater than or equal to, which means that this is a solid line. However, whenever we have negative absolute value of x plus 2, we only have inequality signs that are not inclusive, as you can see. And note here, our y can never equal to that line. So by rights, we should actually be making this a dotted line. So this is a dotted line. And this is to show that our domain does not exist on this line. All right, then we know that that's our first restriction drawn on our diagram, this dotted line for the negative absolute value of x plus 2. Now we know that when y is less than or equal to x to the power 4, which means it's below this curve, which is everything in this region, then our y must be greater than this. So the intersection of those two sets is everything on the outside over here. And now we also know that if y is greater than or equal to x to the power 4, which is this region, then our y must be less than our negative absolute value of x plus 2. So if we're in this region, we must also be below this curve, which is this region. And the only way those two intersect is in here. And there you go, we have sketched the domain of our bivariate function. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.